So my name is Rami Al-Ghanmi. I'm a software engineer at Workday. And you can find me on LinkedIn or Twitter. And before I start, I just want to talk a little bit about my company who sent me here. Workday is a global leader SaaS company. Before SaaS was a thing, Workday was dealing with sensitive information in the cloud, which includes HCM information, your social security numbers, your salary, your deductions, all that stuff, including we are the system of record for most of the Fortune 1000 companies across the world. I'm the public cloud team, where we work with Kubernetes day in and day out, and we provision and deploy the Workday stack in the public cloud, and where my team is recruiting. So if anyone is interested, we're specifically looking for junior engineers. You want to attract more talent, get them through the pipeline, and have them advance within. So if you're interested, please reach out to me after the talk. So we'll get started. To begin with, I'm going to start talking about GitOps. To be honest, I expected that we will have more GitOps talks at scale this year because it is somewhat of a thing nowadays. So I kind of measure the phases in technology with how things are presented at scale. Anyone here was at scale 9? 8 or 9? Okay, do you remember the Git versus Mercurial fight? Yes. That was scale before scale 11. Scale was a little bit religious. So if people came in, if I'm an Ansible guy and you're a chef guy, we came with our boxing gloves. It was all great discussion, but it was very passionate. Now people are more secular when it comes to open source, apparently. So, so the presentation is not necessarily centered around GitOps, but it's around one specific aspect of automating your workflow within the GitOps workflow, especially for monolithic applications, or it applies to you if you have a lot of work you do around data analytics or workflows for machine learning, etc. We're going to talk a little bit about monolithic pipelines, what they mean, their problems, especially in large applications, challenges that we face in application deployments, even in the microservices world, and we're going to talk a little bit about workflows, and then we'll dive into a demo. And if you know me, you know that I always have a live demo, which can go any way, but hopefully things will line up properly for me. I made sure in the past 2 hours I didn't use any of my API keys, so hopefully I won't get throttled during the presentation. Okay, so we'll start talking about GitOps. And I know Hiba said don't ask questions because she's very respectful, but please do interrupt me during the talk if you have any questions. If I feel the question will take too long, I'll tell you to wait until the end. Okay? So GitOps was a term coined by a company called Weaveworks in 2017. They published a really nice blog post where they discussed the concept of GitOps and the solutions they have around it as an organization. And the idea is that you use Git, or for that matter, any version control tool, as the source of truth. Before that time, there were a lot of sources of truth when you do a deployment, right? There is the state of your code, there is your infrastructure as code, but then there is the renderer that renders your code against your infrastructure as code to come up with your deployment code at that moment. So I said the word code like 4 times, and each of those is a place where you can actually fail. So they're trying to clean that up and make actually everything declarative, and all resource management and provisioning is done is declarative and with Git as the source of truth, which means that whatever you're deploying with is pushing code back to Git as it is deploying, because nothing goes in the infrastructure without it exactly being in your version control. So we were talking, if you remember last year, we were talking about the importance of infrastructure as code. It is still important, it is still great, but there is always a diff between code and reality, right? And one of the core tenets in GitOps is to make sure that you actually have a way to go from diff to reality and treat that not as drift, but as a software bug, okay? At the end, we're self-declared software engineers. I always refuse to take that DevOps title because I am still, in heart and what I do, always a software engineer. I have some operational chops, but I am a software engineer at the end. The best thing I do is code, okay? So that's why we always try to, if you look at all these trends, they're always boiling things back to code, back to basics. So and as part of that discussion, they introduced their Weaveworks Flux product, which is a GitOps operator. It's now a CNCF sandbox project, and we're going to touch upon that a little bit further. So to give you a little bit of an idea, if you look at a traditional deployment pattern, things are split into CI and CD, okay? And you have your continuous integration, you have your build pipelines, you do your unit tests, you do your integration tests, you push your artifacts into Artifactory, some sort of upstream Docker hub or anything related to that, and then you deploy your code, and you have an orchestrator that orchestrates your code. So we kind of replaced it works in dev and throw it off the wall to ops guys to you have your CI process and you have your CD process. And different people kind of mix those in different ways. So what GitOps Flux tries to do is injects itself as, Weaveworks Flux, or the GitOps concept in general, tries to inject itself in the process. So if you see that you have code at the beginning, and you have code just before deploying, right? So remember I said you have your code, then you have your infrastructure as code that generates code that you deploy with. Well, it kind of injected Git where it will check in that code that you will deploy with down the line, okay? So everything becomes now trackable as source code, okay? So this makes sense, and to be honest, in a lot of organizations, especially younger organizations or leaner organizations where they have microservices, and a microservice is actually micro, whereas you go to large organizations or enterprise organization where the microservice has like a 2 terabyte RAM footprint, okay? You call that a microservice? Then we have an obesity problem in microservices. So not only that, what happens also is that some application happens during deploy time. You don't have these clean cuts between applications. Not everyone has, for example, a RabbitMQ that's big enough to scale that can manage the interactions between all your components. Certain components need to talk to each other via load balancers or even brokers that are real time. So what happens is a developer will come in, maybe it's an old app, maybe it's a new app, and I'm not ranting at all right now, where I say, how many pods do you need? It's like, no, don't worry, I just need 1 pod. What do you mean 1 pod? You have now you have 20 deployed. Yeah, what happens is that 1 pod comes up, it decides how many pods it needs, and then it's going to request them. So I'm deploying the thing that's going to deploy the other things that I need to deploy without you getting involved. So things like that happen. So there is a lot of business logic that comes as part of the deployment. It could be things as simple as, okay, you need to create these databases, or you need to snapshot this database. We call this database the last week's database, and this is this week's database, and the customer needs both, for example. Or you need to run some specific backup processes. That happens. Okay, so we need to run all that. Now remember, I'm in the CD process. I already had all my code done. I already packaged all my application. Okay, this is just deploying it into the cloud provider. Okay, so we need multiple things to do. We have a lot of steps to take care of where we need to put some code, things fail. We need to write code to do retries. I know what the solution is. Jenkins. Okay. I expected a bigger laugh, to be honest, but Jenkins is this thing that you inject everywhere because it's solid. We've been using it all the time. It is great. I hated Jenkins before I even used it, and when I started using it, I started liking it a little bit, and I started hating myself for that. Okay? And there is this joke that we say about Jenkins, where you end up with pipelines of pipelines, okay? Your pipelines will have pipelines, and you need to wait for them. And unfortunately, I couldn't find pipelines big enough to fit on this screen, but you do find steps after steps after steps where things will take hours sometimes and minutes to complete. And if something fails, the whole pipeline fails, right? So you kind of run into problems where you have challenges that you face when you're deploying things, especially at a macro level, okay? If you have a simple microservice, easy enough. If everything communicates with each other using gRPC and you have canary releases, good for you, okay? But there's that, and there's the real world, and there's the real world of enterprise applications with complex dependencies. So things kind of need, like the people who say, oh, you deploy every 7 minutes like yesterday, it's like you just make me feel bad when you say that. Okay, I do deploy often, but not every 7 minutes. That's the dream. But anyway, so the idea is deploying microservices does not mean you're deploying applications, right? Applications require a life cycle of its own at the application level. Okay? We are like SREs, DevOps engineers. We are SMEs in almost everything. We brag about how good we are. But the one thing that we really don't want to touch, even though we're good at it, okay? We don't want to debug application code. We don't want to figure out why this integration test failed as part of this deployment. I don't want to deal with that, right? I want to get a repeatable way of fixing that. So enterprise applications cannot, even though they're microservices, they're a monolith of microservices that come with their own complexities, with their own problems. So they have dependencies on other running applications, third-party services, stateful services that need to roll over. If you have a tenant, for example, that you need to run through a lifecycle event, okay? Or you have integrity checking that you need to do in order to comply with audits or for security reasons, and you have your own technical debt that you need to manage, okay? So pipeline stages as code is a good idea. I would love to have my pipeline stages as code, but I really don't want it to be groovy code, to be honest. I want it to be something that is repeatable. I don't want to write a middleware. I don't want to write glue code around my deployment. I want it to be something more native to what I need. So this is where the concept of workflows come in. The concept of workflows was introduced way back when in the 1930s, okay? And looking back at the most basic definition of it, and I highlight some of the important words that I wanted us to see and understand on what a workflow is. So a workflow consists of an orchestrated and repeatable pattern of business activity. So you have a bunch of activities, okay? They need to be orchestrated. What goes in parallel, what goes serially. They need to be repeatable, which means that if you do it once, if it breaks, if you do it again, it may work, okay? Or if it breaks, then you can repeatedly break it to make sure that you have a problem and you know how to fix it, okay? And these are processes that transform what you have in your own organization. It transforms the input that you have. It could be code, it could be business logic, it could be something else. And it processes that information in a sequence of operations. So it's a complex definition, okay? But at the abstract level, it kind of captures what we want and what we have. So kind of, if we look at it, what do we want to have in a workflow solution? Number one, it's not Jenkins, okay? So that's one thing. And sorry, I know the Jenkins people are around here. It's an amazing piece of software. I just like other software more. So it should be simpler to use than Jenkins. Jenkins is quite complex. If I grab a software engineer who said, I want to start in DevOps, I say, okay, deploy Jenkins using Docker on your laptop. Come to me after a week, okay? It's not an easy thing to do, okay? You need to define all the different agents. You need to deploy Jenkins in its own way. You need to add all the plugins to integrate all the pipelines. So it's quite a bit of work. It needs to be easy to set up. It should be easy to operate, Okay? It should be modular, so there are components that I can take in and out, or I can reuse components, basic software engineering principles. It needs to be scalable, so I don't worry about it crashing because it ran out of memory. I don't worry about my whole deployment history going away because the master got lost. Okay? It supports lightweight executions. Jenkins specifically has a high cost for executing agents. You need to boot a full agent to get any job to run. And I could be wrong, and most likely I am wrong with the new stuff they have in Jenkins X, but still, it's the way we use it right now and the way everybody uses it makes it really expensive in that matter. Also, we want something that supports timeouts and retries natively. Okay? I don't want to write my own retry code. I don't want to inject code that finds the retries. I want it to be able to figure it out on its own. I want it to be cloud native, so it provides the standard stuff I get with cloud native solutions. It supports multiple backends. It has multiple providers. I can get logging. I can get metrics. It uses some of the standard tooling we have. I have reproducible steps, and I don't want it to be a service. Okay? I want to deploy it on my own. I want to own it. This is a critical piece of infrastructure. I really don't want it to go. So there are a lot of solutions that actually provide that. So you have Apache Airflow, which is a very common solution. You have Jenkins, which it's a Swiss Army knife. You literally can use it for everything. And there is Spinnaker also. And Spinnaker is quite an interesting tool. I actually was a big fan of Spinnaker before I got into Argo a little bit more. Some of the drawbacks about, anyone uses Spinnaker here, by the way? So I can't talk trash about it? Okay, no. So Spinnaker is a really interesting tool. It came out of Netflix. So the first thing you know about if it came out of Netflix, it has like a gazillion microservices just to run Spinnaker. Okay? It needs also, it's an orchestration tool. It's not a build tool. So you actually need to have a tool that builds for you as part of Jenkins running that does the executions. And it leans more towards infrastructure as code as opposed to services. But if you're a person who uses AWS a lot, uses cloud a lot, and you deploy directly as AMIs, and you have your Jenkins jobs as atomic units, actually Spinnaker is a really, really nice solution for you. And especially at the infrastructure layer. What I'm talking about more here is demystifying the CI process where the deployment of the application itself. This is where Argo comes in. So Argo is an open source tool. It's a Kubernetes native workflow engine. And it uses something called CRDs. Anyone familiar with CRDs? Okay, good. Not as much as I wanted, but so think of it this way. If you're familiar with cloud, you have your compute. For example, in the world of AWS, you have your EC2. You have your storage, okay? And you have your other components, your networking, et cetera. These are the primitives that you build with. Kubernetes gives you an abstraction layer, okay? And as part of the abstraction layer, it defines specific components. So you have your pods, you have your services, you have different components that you interact with in Kubernetes itself. CRDs, or custom resource definitions, is a Kubernetes way of telling you, you can define your own resource, okay? You can define your own resource type. As long as you can talk Kubernetes API, create your resource type, deploy your services as containers. Whenever someone asks you for a specific resource, whenever someone wants to do an operation on that resource type, an API call will come to your services, which turns out to be a very strong part of Kubernetes and one of the most growing aspects of that platform. So what happens when Argo is deployed as a CRD? First of all, it runs all its atomic steps. All your operations are run as containers, which means that as long as you're able to build your container, okay, you're able to inject it to be part of your workflow. And it captures dependencies. So if you need to say, I have component A that needs to be deployed, then I need to run this operation, and then wait for component B to be deployed. Then after that, go ahead and deploy component C. Before that, C doesn't even get mentioned, okay? And we're going to see hands-on examples of all of this, okay? And also, it kind of makes your pipeline a first-class citizen of Kubernetes. Some of the nice things that you get for free. So let's say you have a workflow that has a component that says create database operation, okay? And that component in your workflow went ahead and tried to create the database operation. The cloud provider did not respond saying the database was created, okay? So the container errored out and crashed, okay? Without any extra code, because this is a Kubernetes component, okay? Kubernetes will say, oh, this crashed, let me try again. Crashed again, okay, let me try again. It crashed, okay, I'll do exponential backtracking. So even as you got all that for free, just by the premise of it being in Kubernetes. So even Argo itself is a lightweight solution compared to other more complex pieces of software when it comes to this. Any questions so far? Okay. So talking about, if we go back to the workflow again, when we look at the orchestration component, the orchestration part is done by Kubernetes. Repeatable patterns, that's done by your workflow components, and each component in that is a container, and as we know, containers are immutable, so if a container goes away, another new one comes in its place, and that's the definition of being repeatable. And the process is the flow of your workflow, okay? And that defines your sequence of operation. So now it's demo time, okay? So let's go here. Everyone is able to see the screen properly? I didn't get an answer. Okay, so I'm going to take that as a yes because I cannot do anything more. So some Kubernetes cluster to test their Kubernetes clusters out. So that was a really nice way to start just to bootstrap myself. Wrote some small Terraform code that will provision a Kubernetes cluster. Why didn't you use another cloud provider like EKS, AKS? Well, I didn't use Google because they'll charge you $75 just for having the cluster, right? If you're following the latest advancement there. But DigitalOcean gives you a nice way to bootstrap yourself, so that's a plug for DigitalOcean. Thank you for the credits. And it gives you all the basic primitives that you need to start with. Any other cloud provider will make this work for you. You just need a basic Kubernetes cluster running, okay? After we have the Kubernetes cluster running, we will go ahead and deploy some of the basics. We're gonna inject some monitoring applications there. We're gonna deploy an ingress controller because, as you know, Kubernetes by design manages its services internally. What we're gonna do with an ingress controller is that we will be able to take traffic from the outside into the cluster, and Kubernetes will manage all the traffic coming in. That's one. Two, we are gonna use Let's Encrypt to encrypt the traffic, okay? Although nowadays it doesn't matter, apparently Intel has a bug where whether you encrypt or not, it doesn't matter at the processor level, but we'll do our best to be able to accommodate that. So it'll actually provision the certificate manager for Let's Encrypt. It will call Let's Encrypt upstream. It'll get the new certificates. It'll install them, okay? And then we have that done. We're going to install Argo, and we're going to go example, and we're going to install the Argo UI. So we're going to see how we can do the things by the command line, and we're going to see how we can do things via the UI, okay? And one of the cool parts about this is that all this fits in one letter page of paper, okay? All the code to do this fits in one letter page of paper. So let me pull in, and in retrospect, I actually should have, where is it? Oops. Where is this? Oops. Sorry. So here's the repo for, I'm not going to go into all the code details, just because in terms of deploying the infrastructure component, that's just Terraform code, very simple to read, you can go over it, nothing complicated there. And like I mentioned, we're going to start by deploying the Kubernetes cluster, then we're going to do some basic setups, and then we're going to do some workflows. And it's generally done in, should be done by now. So anyone who uses Kubernetes here? Okay, do you have it in production? Meh, kind of? You either do or you don't, buddy.
We use it for GitLab CI runners.
Okay, that's nice.
Yeah, but that's not like deploying applications. It's deploying it's deployment infrastructure.
It's the deployer for your infrastructure, basically.
Yeah.
Okay, that sounds nice. What cloud provider are you using?
We're married to AWS right now.
Okay, are you planning to continue the marriage?
Right now, yeah.
Okay, good luck.
There hasn't been any divorce court mentioned yet.
Okay, that's good to know. That's good to know. Okay, so now what happened is we deployed the Kubernetes cluster. So we're going to actually make sure that we have the Kubernetes configuration file done. I'm going to put the Kubernetes configuration file in the standard location just so that makes life easier while we're going. You guys can follow with me, right, as I'm working here? Okay, great. And then, who's familiar with Helm here? Okay, great. So Helm, think of it as the package manager for Kubernetes. And one of the cool things is a lot of the services that we're going to use actually come packaged as Helm charts. So that makes the deployment quite easy. So what I did right now is I actually declared Helm charts. And what I'm going to do right now, the first step is I'm going to clear the screen after every step. The first step is I'm going to create a namespace for Kubernetes monitoring, and I'm going to deploy the metric server as a Helm chart. And the metric server is basically a component in Kubernetes that collects metrics about CPU and RAM utilization. That gets used quite a bit to make sure that you don't run out of resources and your resource management is visible to you. That information is available to the kubelet, but you want to make sure that that information is also available to you. And as you can see, it's basically a one-liner here, and it gets deployed. And we'll do all our checking in a bit after things happen. Now, ingress. Now, we will have the Kubernetes, we will have the containers running in Kubernetes. We will have the services running inside Kubernetes, but we want to be able to access them from outside. So we kind of need to create an input from the outside, and we call that an ingress controller. So like everything nice in Kubernetes, we need to create a namespace for that. Okay? And then we're going to use Helm to install the Nginx ingress. Why Nginx? Well, I'm mostly familiar with Nginx. If we wanted to go fancy, we would have brought in Istio, but that would have added more complexity. Yes? So within your context, what's happening is you're using the one cluster for all your environments, right? Namespacing has an additional feature in Kubernetes where you can use it as a construct to manage RBAC, to manage access controls, read, writes, updates, etc. So you can say, if I have an application where everything inside that application, if that application has 5 microservices, those microservices can talk to each other. They can share secrets with each other. They can share config maps with each other, okay? You can enforce that in Kubernetes. And you can say anything outside, it does not get to see it. And anything from outside of there cannot go in except X, Y, and Z. So you can use namespaces to enforce that. And that's one of the cool features about namespaces and what you do. And sometimes you use it just for a logical separation. Here are all my monitoring applications, here are all my ingress stuff, and you can go more fine-grained. But it helps a lot in RBAC controls, okay? So we set up ingress, and then we're creating the ingress controller. And what happens with the ingress controller is that it creates actually a load balancer. So it went to DigitalOcean, said, "Dear DigitalOcean, I need a load balancer from you because somebody needs to talk to me from the outside, because if you see here, the cluster IP is a 10 dot IP, and that's accessible only from within the cluster. But the external IP is a 159, which is an internet accessible IP. And that I got that from DigitalOcean because they provision a load balancer, they put an IP up front, and I got that IP. Now, what I need to do with that IP, I need to configure DNS. Okay, so I can access my resources using DNS. So, before I'll do DNS, I want to do one thing. I want to manage the Let's Encrypt certificates. So I want to install the Let's Encrypt component first, which is called Cert Manager. And for that, we're actually not using Helm. We're using the upstream chart for that. Okay, and we're creating. Sorry, I did some preparation. We're creating Cert Manager. Sorry, I messed up. I was just putting in some prerequisites where I created the CRDs for Cert Manager. But after I did that, I'm going to use Helm to deploy the Cert Manager. Everyone uses Let's Encrypt or familiar with it, right? Okay, the basic idea Let's Encrypt is certificates, valid certificates on demand, right? You're able to mint certificates as you need them. So this is what we're doing for with Let's Encrypt. So we installed this, and we want to make sure our Let's Encrypt components are coming up. So we see 2 pods are up, we're waiting on 1, and last one is running, waiting to get ready before we can go forward. Okay, and that is ready for us. The next step is to define the Let's Encrypt issuer. So this is something I wanted to show you, just so we understand what's going on. The basic idea is to provision a Let's Encrypt certificate. You use the Acme protocol. You call the Let's Encrypt endpoint, okay? And the Cert Manager will do all the validation for you. It'll take that certificate, create a CSR, private key, CSR, send the CSR over, and then it will grab the certificate and drop it in a secret so your service can use it. So we're going to do that for the Let's Encrypt prod issuer because the staging one is invalid. Now, like we discussed, we had the ingress controller IP, the 159. So we needed to update our DNS, and I'm just going to do some fancy scripting where I am going to get the IP address in an environment variable, and then I am going to feed that into some Terraform code. So initialize Terraform. As you can see, it's adding 3 Terraform records, okay, that we're going to use later. I'm going to say yes. Please create them for me. And what I'm using here, I actually have the DNS records in Cloudflare. The example, yes? Mm-hmm. Mm-hmm.
So this talk is about GitOps. The time it would take me to write scripts and validation to add the other components, the ingresses, and cert manager and everything else, is kind of a pain in the butt. This talks about GitOps. Is there a good GitOps way of standing up the cluster basics plus all the components?
So, so you always need a kernel to start from, right? So you need to have your admin cluster, like the gentleman here was talking about. You need to have your root that you will deploy from everywhere. So that one, you actually need to deploy maybe by hand or maybe by scripts that are a little bit painful, and you try to automate as much as you can. But once you have that, and you have all your tools set up, then you can use that to deploy. And what you're looking for is more of a CD process as opposed to a CI process. And that's something that Flux and Argo CD are good at. And we're going to touch upon it a little bit later. Okay? What we're trying to concentrate here more is about the workflow process. Because the DevOps stuff, we figured out already. It's the guys who deal with the applications that have the more complex scenarios. But even if you have those complex scenarios, when I started, I wrote this where I did all this, and then I wrote the workflow to generate this another time as a workflow. But when I did the demo presentation, it was too complex for people to comprehend. So I went with an easier path. But we can talk a little bit more about it after the talk. It was more like an inception kind of thing. Okay, so so we created the DNS records right now, and then I am going to start the deployment of Argo. So we're going to create the namespace that is called Argo, and we're going to deploy Argo using the upstream manifest. Although it is packaged as a Helm chart, the Helm chart is community supported. The manifests upstream are managed by Argo themselves. So I went ahead with the upstream stable release. Yes?
So that has the definitions of all the, I know it's YAML, but what do they call the templates that Kubernetes use?
YAML templates.
Well, no, not YAML, the ones that have like API versions and everything, like what are they?
The resource definitions, the CRDs, it has everything. Okay. So actually, if you just click here and it'll take us to the browser, you can. This is one giant YAML file that has all the resource definitions, and it's separated by 3 dashes. Oh, sorry.
You can do that. Is that legal YAML?
That is legal YAML. Okay. There is one thing that is not YAML legal here. There is one thing that they didn't do with YAML. Anyone figures that out? That's like brownie points, bonus points. Okay? A YAML object always starts, a YAML file always starts with 3 dashes. Okay, they don't have that. Okay, forgive them for that. It's okay. But there's one obscure thing. And if you ever take, by the way, the Ansible Red Hat test, this is one of the questions usually. What does a YAML file end with? Excuse me? Nope. 3 dots. Dot, dot, dot. That signals the end of a YAML file. That is in the definition of YAML, yet another markup language. Though interpreters basically ignore that. But you'll run into it at some point, and remember me, you can thank me on Twitter later. Okay? So if you look, sorry, I thought you had the terminal. So we deployed Argo, but what I want to do right now is, although Argo is available as a CRD, I want to deploy Argo as an ingress service, so I can access it from outside. Okay? Oops. Okay. And let me see. And what I'm doing right now is actually waiting on the Argo certificate to come in. So what's happening right now is we created a Kubernetes cluster. Doesn't matter how you create it. We enabled metrics. We set up Let's Encrypt so we have the right certificates. We set up an ingress controller, okay, where we can get traffic from the outside. Kubernetes will take care of managing traffic internally, but we want to make sure that we get traffic from the outside. That traffic from the outside will get a certificate from Let's Encrypt, so it'll be a valid certificate, okay? And then we can hit the Argo URL based on that, okay? And any questions? Oh, we have the certificate there. So if we go to the browser, and we go to, and there you go. We have the Argo interface already there. And as you can see from here, we have a valid certificate. So good traffic through and through. I know this took us a while to reach here, but trust me, it'll be worth it. Okay. So now we're gonna start setting up our workflows. A workflow is basically a set of steps. Each step fits into the other, and we will go and we will create those steps as we go there. When we start, because of security reasons and because I don't know what Argo will talk to, I'm actually going to limit all my workflows into one specific namespace. But one really, really cool thing about Argo is that when you trigger a workflow, you can actually give Argo a service account. And that service account credentials will be used for that workflow. So if you have a workflow that needs access to a database and needs access to the web portal, then the service account will allow it to access those two namespaces or those two applications, but it will block it from everywhere else. Okay? So that's one of the cool features that I really like about Argo in this context. So what I'm doing right now is I'm setting up the Argo namespace, and I'm allowing Argo to go wild within that namespace. This is what I'm doing with the role binding. Now we're going to see our first Argo workflow. Okay? This is a simple, oops. Oh, sorry, guys. I thought you had the terminal on. Okay. So we will have our first Argo workflow. The Argo workflow is identified as follows. Since we have CRDs, it is of the type workflow. Some of you are used to having pod, service, etc. This is called a workflow. This is the generated name, which is the name that will be given to pods as they come up to service this workflow. I put it in a namespace. You don't need to put it in a namespace. I chose to do that. It depends how your posture is in your cluster. Then the entry point. You're familiar with Docker entry point. What does the Docker entry point do?
The first command that gets executed if you don't give it another.
Great. So you will have multiple steps in your multiple templates in your workflow file. Okay? So you get to decide which of these is the entry point for this workflow. Okay? It's the same definition. And then we define a template. The template is called whalesay. Whalesay is basically one of those Docker example containers where it brings up a whale and you get to see, it gets to say something, and you give the text that it gets to say. So basically, it's a one-step workflow just to see how things work in Argo. Any questions so far? Nope. Just standard Kubernetes YAML, whether you like it or hate it. I personally like YAML and hate Jenkins, but I'm different.
Real quick question.
Yeah.
So I saw you defined the entry point, but at the same time you gave it a command, like output command. That overrides the entry point in this case, right?
No, the entry point is the workflow entry point, and that is the name of a template. Okay? So you can see that that they match here, right? Okay? So now what we're going to do, we're going to use basic kubectl commands to create the workflow, okay? And you can say, it tells you that a workflow was created, okay? And then you can actually say, get workflow, and you can see that the workflow is running. It's like a standard Kubernetes component. I'm just doing some scripting fun here, and I'll say, get the workflow. It tells me that the workflow is running, and then I want it to see the pods, okay? And they ran, and they worked just fine. And then I can actually see the logs for the pod that ran. And the log just shows me the way I'll say. So this is the output of that step, okay? And if we go back here and we refresh the page, you'll actually see that this is a workflow. It's a one-step workflow. This is the YAML of the workflow that we just saw, okay? And this is the log file from the workflow, okay? So there is a UI. It's not the first thing that you use. Personally, I'm a command line guy, but it helps you in visualizing how things worked and what they are, okay? So now what we're going to do is we're going to try another workflow that is a little bit more complex. Now, Argo has a command line tool that is Argo CLI. And the Argo CLI is basically a wrapper around kubectl, okay? But it has some additional features that pretty prints the process of your workflows. So we're gonna look into a new workflow that's called Coinflip, which basically it is a workflow. I have the Coinflip template, and what it does, it has 3 steps. Step 1, it'll flip a coin. Step 2, it'll run 2 things in parallel. It'll check whether that flip was heads or that flip was tails, and it will report it as such. So if you see here, this step will run when the flip coin result is, we'll check if it's heads, and this one will run to see if it checks it tails. The cool thing about this, that you can have them run at the same time. So it is literally speculative execution, okay? So, but at the workflow level. Speculative execution, rings any bell? Spectre and Meltdown, yes, thank you. Okay. And this is the definition of the flip coin. It's basically a script that flips a coin, a Python script that flips a coin, okay? And if the coin is heads, it'll call the heads template, which echoes it was heads. If it was a tails, it'll execute the tails template. So this one has multiple templates in it, but we had a conditional that decides which thing runs, okay? And the way we do that is and this time we're going to use the Argo command line script. And you will see it's initializing the pod. That's why you see a question mark. Once the pod is running, why is the pod taking too long? Oh, it's copying the images because this is a new cluster that I created with you. Just a second. And as you can see, it flipped a coin. Because it flipped the coin was heads. It ran the heads line, and we got the result for heads. So if we look here, and we go back to workflows, and you look here, you see that you started here, it flipped a coin, the coin came out as heads. Okay? Now, we have 10 minutes left, so I'm going to go a little bit faster on a couple of examples, if you guys don't mind. Was there a question? Just, yes? Yes. So all the pods died, but it will keep the workflows. If you think of them as Kubernetes jobs, so you can say list, and it will list the workflows for you, what succeeded and what failed. Oh, sorry. My bad. So you basically say Argo list, and it will list it for you, and it will say what succeeded and what failed in that regard. Okay? The second workflow that I'm going to run, and for that I want to do here, this is a recursive Coinflip. And what the recursive Coinflip does is that it keeps trying until it gets heads. Okay? So if you go here and you click on it, you can see it thinking and thinking. It tried heads. It got heads from the first time it stopped. Okay? Let me try it another time. Hopefully it'll show some recursion there. If not, we have some other cool ones that I can show you. For some reason, my machine is biased towards heads. I don't know why. Oh, come on. Okay, one last time. Okay. Come on, tails, tails, come on. Okay, this is not working for me. So, but even when I was trying it, I was like, no, it'll be random next time. Well, I think I talked enough about Intel that they're mad at me. Okay, so the one I want to show you right now is a looping. Okay, so if you're, yes? For the Coinflip? Okay. Sorry, for which example? Oh, okay. So if you used YAML, okay, if you used Ansible, the logic, it's very similar in the way it's done. Valid point. Valid point. Maybe actually valid. Yeah, you're right. You're right. I actually will review that. Thank you. I will check that afterwards. Appreciate it. Okay, so now what I'm looking at is loops. And what you see here is that I am running a test. Oh, thank you. I should be mirroring screens. So what I'm doing here is basically I am iterating. I'm testing different releases. So I'm downloading all these containers, okay, Ubuntu, Alpine, and I'm basically just downloading the tag and then I'm outputting the release, okay, /etc/os release. So if I run this, and you're seeing here, and if we go here, you'll actually see them each executing. And you can see the results from each one as the logs come out. Okay? Now, all this is fine and nice, but for the interest of time, I want to jump to something more interesting. Okay? So what I'm going to do with this one is I am actually going to show it to you running, and then we're going to look at the code because it's a little bit interesting. So what I'm having loops and conditionals in the middle, which has a diamond-shaped DAG, direct acyclic graph. So if you have something that you're trying to achieve in the bottom, okay, you will only reach it when D is only executed after everything else before it is executed. right? So you're executing A will have 3 children, but B, if you look at B depends on A. So if you look at the YAML, okay, B has a dependency on A, so B will not execute until A was completed executing, and A had 3 parts in it. Okay. And A had 3 parts running in it. So when all 3 parts of A completed, A was able to run. And C, am I at C right now? Yes. C depended on A running. So after A completed, we were able to get both B and C running, each of which had its own 3 executions, but D itself depended on A and B running. So it depended on both B and C to finish running. So D was not executed until D and C ran, and then D ran and reached its conclusion. So the reason I showed this is that it shows you the dependencies and how they work as part of your workflow. And this has a lot of power when it comes to trying to implement business logic. And the idea, think of it this way. A, B, and C, they're containers, okay? So if you want a new version, you do not care that they change. You can tell the team, dear team, this is your workflow. Update the container using your own software release process. Once it goes to production release, that's what I'm going to pick up in my workflow. That's what I will implement. And if anything fails, you know which part explicitly failed. Okay? And it's a repeatable fail because there's no state stored in it as it stands. Okay? One cool thing that we don't have a chance to see here is that artifact management. So actually, Argo allows you to store artifacts in Artifactory, S3, or any of the object stores that are available. So you can actually declare a state for a specific object, and that state gets pushed into your object store for another template or even another workflow to pick up. Okay? So any more questions? Well, thank you very much, and I hope you learned something about Argo and workflows today. Thank you.